Oh, thank you, Josephine. Yeah, so a second talk for me today. Now I'm not alone, which is good. Yeah, we prepared this. Oh, please help me. Yeah, so, okay. So about us, this is Gerd. I learned Gerd to know 2 years ago, I think, at an evening event from the Cloudland conference. We had a good talk there, and yeah, this is then we started with the implementation of all this stuff, and yeah, then we needed help, and so I contacted him, and he joined our team and helped implementing the accounting stuff. Yeah, so.
Yes, thank you, Matthias. Yes, we met at Cloudland at an evening event. It was a long party, so don't forget to socialize with your people. It's very important because you can get a contract via this way. Yes, I was happy to join Eurotech last year. I think we worked almost a year together on this accounting stuff, and it was very interesting for me. Normally I'm working on the very high level on application development, and now I could dive deep into things close to the metal and the very nature of our computing facilities and infrastructure.
Okay, so what's about? What is it about? We provide cloud infrastructures at Eurotech, and we have some products there. We built some products there around, and we decided not to reinvent the wheel from scratch, because we say there's enough good components in the open stack in the open source world. And the first layer, which I want to show, is the bare metal provisioning. So this is based on cluster API. It's a little bit dark, the painting, but yeah, let's see. Yeah, so basically you have at the bottom you have a management cluster which has cluster API inside, and you have a provider which is called Metal Cubed, written Metal 3. This uses OpenStack Ironic standalone for the bare metal provisioning API, and at the end you will get a Kubernetes cluster on bare metal with the network configuration you set in the declarative way in the management cluster. You can also provide multiple Kubernetes clusters on bare metal with this engine. And yeah, so we built some stuff around Metal Cubed and OpenStack Ironic. We improve as well OpenStack Ironic for several things which are not working out of the box, and also bringing them upstream. And yeah, so at the end you have a Kubernetes cluster on bare metal. We are solving this problem in this way, and then we are ready to run Yaook or to deploy Yaook and OpenStack on the bare metal machines. So the next layer, that's the IaaS layer. It's driven by Yaook. Is the OpenStack cloud platform from Eurotech called UStack. Yeah, we have there the Kubernetes cluster, which is the base for everything. And I always say, if you have Kubernetes, at this point, everything is easy. And it's really like that. Yeah, at this point, you can just deploy your applications or your services, or so you can deploy your DNS service for the platform very easily, and all the stuff you need. This is really helpful to have this Kubernetes cluster, and Yaook does the rest, I think. Yeah, so for the OpenStack part, at least. Not everything is not perfect. Yeah, if you are in software or hardware, you know that. But you can improve it. And yeah, basically we have there the operators. They deploy the OpenStack services. They provide the ingresses for accessing the OpenStack APIs. And then we have also UI, which I show later some pictures for UI. And yeah, then basically you have the OpenStack running, configured, declarative, and everything in a Git repository, provided with the GitOps operator. And yeah, so this is our approach. And then we have some Kubernetes as a service running on top. I don't want to go too deep into that. It's also just for having this everything around view. Yeah, so then we provide some UI. Yeah, this is some screenshots of our OpenStack UI we are implementing. So this is everything open source. Yeah, so we have it in the repositories in our GitLab organization. Just to show you what we are thinking about this stuff. And sorry, I think I put the wrong resume. Help me, God. the Mac is doing something.
I wonder which key you press.
Yeah. There's a resume. Yeah. Yeah. Okay. Thanks. Yeah. Yeah. So let's finish the UView slides, and yeah. So, what are the challenges from our perspective? Yeah. So, the amount of topics, we heard it in the panel discussion before. The amount of topics, the complexity of all these topics is really a big challenge in our opinion. We have, if you are dealing with bare metal, you have firmware related stuff. For example, if you have some high-speed network interfaces, you will get them from your provider, and usually they have old firmware. And before you can use them, you have to flash them. And if you think about bare metal provisioning, this is a chicken-egg problem. Yeah? You have to flash the firmware before you can use the NIC, but you want to bring up your engine, and this is something you have to solve. Just to mention some sides from this, and the BMC firmware is also a thing for us at least, because we use it intensively for the provisioning server BIOS as well, because usually you want to have the same BIOS settings, or you want to have them under control for all your servers, which is not open from every server vendor in the same way, at least. And also big point, which we also heard from the discussion in the morning, from the panel discussion, is this building open source software and having paying customers for that. Yeah, so because you want to build good stuff, and you need customers who pay the guys who are doing that. Yeah, so and you have to find a solution for that, and this is something really challenging in my opinion. It's not technical, but it's also something very important. And yeah, and then if you build this cloud platform, at the end, you want to have the opportunity to account or bill the resources you have. And we had a look at the stuff which is in OpenStack already. And we talked to other people who are doing it or using it, and they told us, oh, it's regarding performance, you will have issues. And the plan is to build a large-scale platform with that. And then we said, okay, let's have a look into it from the software engineering perspective, and Gerd will tell you more about it.
Yes, thank you. Let me jump to just a very high layer, and this is about the value stream. So in the end, the core of the talk is about earning money, getting money out of your product or whatever, and this is something I like to address on the business level at first hand. And let's look into some value stream. Usually you have several steps. You do some whatever cloud provisioning, and you introduce customers and everything else, and they book products, and booking products in fact means they provision infrastructure somehow through an API or UI or whatever, and this results in running infrastructure, and this is something you want to build to your customers. And I'm not going into the business software behind it, so maybe in the end you have some accounting data gathered from the infrastructure layer and push it into some SAP or something, but nevertheless, the accounting is between spending money, so provisioning infrastructure, to earning money, so getting something back, some revenue from your customers. So sooner or later, everyone who's running a cloud has to think about it and to get some idea on how to make money, or maybe you're not making money, maybe you make experience or whatever out of it, but you have to do some billing based on accounting data. And that's what we are doing. We are going through, we went through the order to invoice journey, which is from left to right, from the value stream. We looked how to provision the product into provisioning resources, and then aggregate the usage of the resource, and have some billing in the end which maps back to the product, because customers are usually billed for the products they bought, and sometimes it's a one-to-one mapping to resources, but in some cases, if you have bought a service like Kubernetes as a service or database as a service or something, you are not interested so much into the breakdown of the infrastructure, but you want to get a bill covering the product. And yeah, this is one of the key takeaways for me. Try to define your product first. So this was one of the challenges we had on our journey, that the product was a little bit fuzzy. It went this or that direction, and this made it sometimes hard to define a good architecture for it. On the one hand, you want to have an architecture which is able to change. So business changes over the time, so you must be able to adapt. On the other hand, you need some clear vision, or some, at least at the beginning or every time in between, you need some clear vision on how your product works, how you break down your, so to say, your product to resources, and how you map it back to billable items. So this is one of my or our advices. So what did we do? On the business level, we tried to evolve the business context. We used a technique called domain-driven design. Maybe if some of you are software developers, you already know about it. It tries to find out the important domains of a company or whatever, of every stakeholder, and how the domain or subdomain works. And yeah, I do not go too much into details. There are techniques to get some idea how the stakeholders see their domains. You can do some user storytelling. That is what we did with some customer to get a good understanding, and then evolve a context map of different contexts where the things happen in your overall business. Ideally, you define some clear bounded context so that billing is only affiliated to billing, while provisioning does only provisioning things, and you do not try to mix things up, which is sometimes a hard job. However, I hope we found a good solution for that. And then you try to strongly maintain this separation of concerns, not to mix up things. And in some points you build up a ubiquitous language, which means you have a clear understanding also in terms of language, in words, what you use, phrases, sentences, how you describe your business, and use it not only on the business level, but also on the technological level, which is also something we tried to achieve. So this was mostly about the business perspective. And then we can go into the technical architecture. This is the overall system context. So you see we have the different layers of the uCloud system, like the metal, the uStack, uGarden, uView. These are the different layers. And on all, or at least on most of them, you provision infrastructure. All of this infrastructure contributes to the accounting domain. So you gather data from the different levels. In our case, we can restrict it a little bit to OpenStack. We also tried to think about other cloud infrastructures, but in the end, now it's mostly OpenStack. So you have some OpenStack API, and you try to get accounting data from it, aggregate it, deliver it to the presentation layer for users, customers to see it, but also to other systems behind it, like billing system, correlate it to user context, to business context, to your products, to your pricing lists, etc. So this is the core of our architecture, or the system context for the accounting system. Well, we were faced with several challenges. I will not go deeply into everything here because of time restrictions, but feel free to get us at the Eurotech booth later to discuss details if you're interested. These four are some of the major challenges. We tried to provide an infrastructure or a solution for a multi-cloud environment. We were faced with complex dependencies. We have the strong requirement of zero data loss, because you want to bill users with the cost for their infrastructure, and therefore if you lose data, you lose money. So this is something very hard restriction or requirement. And we looked into existing solutions. We can go a little bit deeper into it, but not too deep. multi-cloud environments, we focused on OpenStack, but we also looked into GridScale because one of the customers wanted to provision GridScale. We have different APIs on each platform, different event models, different data models, so it's very hard to find a unified approach for multi-cloud environments. We have complex dependencies between them. We need to understand some product concepts. We need to understand how the technical provisioning in fact works and how the breakdown of the products results in resources and how they are provisioned and at what point in time we can charge for them. Maybe if you provision a virtual machine, it needs some minutes to take to come up, and when is the right point to start billing for it, etc. Then I already said we have this zero data loss tolerance. We do not want to lose any data. Maybe at some point it's not possible, but we try to reduce it as much as we can because it has some financial impact directly onto your business. So try not to lose any data. We will come back to that. And then we looked into existing solutions, so maybe not start from scratch, but find something as a good starting point. In OpenStack there is already CloudKitty, but we wanted to be multi-cloud, so CloudKitty was not the right way to go, besides other means. But however, what was a good starting point for us was, on the other hand, the SCS metering. There was a proof of concept done some 2 or 3 years ago, I think, and we started with that, at least for the OpenStack approach. However, but in the end we came up with the decision that we need a custom solution which can handle different cloud providers. So how will we do that? Here again, when we had this decision that we need a custom solution, we thought about different architectural approaches. And as I said, I will focus on the OpenStack, but we thought about several variants. We could just build completely separate services for each cloud provider, which has some drawbacks. You can imagine you have to handle different APIs, you have to consume different input data, and have to provide a complete isolation of the services. Second variant would be we have a common API and have some adapter for each provider, which goes into the direction we finally chose. So we would like to have a single API, like for the billing system or whatever other stakeholders which are interested into the accounting data. We give them the same API independent of the cloud provider, which also is a little bit challenging because you do not have all facilities from each cloud provider. So it's an abstraction somehow. So you have to carefully choose how the abstraction looks like, and then just build some adapters for the input data, which adapts it or transforms it to the abstract interface. The solution we finally choose is this one. We have a common API and a unified implementation. So we have one service, one accounting service, which can grab data from the different providers, which was possible in this case because, let's say, OpenStack to some degree is a superset of the facilities of GridScale. So the most important things we already found in GridScale, and OpenStack provides us with a little bit more data, and we could use it. So in this case it was possible, but maybe if you build another solution, maybe you have to take a different approach. On the other hand, now we have a lot of conditional logic depending on which resources we try to aggregate and which is the provider. So we have a lot of conditional logic for each of them. And then maybe another approach would be to have some kind of a plugin or extension architecture. But but my personal view is that start with a plugin architecture as soon as you have 4, 5, 6 different providers. With just 2, it didn't make so much sense, although in the long run it might be a good idea to go for a plugin architecture where you have some framework and then can plug in the specific adapter for the respective provider into it. So we ended up with something like this. We just have a service which has a we just have a service, the accounting service. It communicates with OpenStack via 2 ways. On the one hand, it's based on messaging, so it grabs or it receives data via a RabbitMQ, but I think it could also be a Kafka or something else. It receives change events from the OpenStack API. You can configure Silometer, and this is the preliminary work we used from the what's it called, Lot 13 work in the SCS context, and we can receive data, but additionally we very early got an understanding that we might miss data at this point. So it might occur that some messages get lost, although it's a high availability messaging stack. So we decided, thanks to Mark, with some extensive discussions, to also build some kind of a second approach where we try to frequently pull the data and make sure that even if we miss some events, we still get some current state of from the OpenStack API, which is also a little bit in discussion because some people claimed we didn't make the experience up to now, but some people claimed, okay, the OpenStack API might get overwhelmed if you have too frequent pulls, etc. But yeah, this is something which needs to turn out during our practical experience in the next month. And yeah, then GridScale, you see we have just a second adapter which pulls data from the GridScale cloud, and yeah, then we store everything in a data layer, have some business logic to aggregate it, store it in a database in a Postgres with some time series extension, and provide it to our consumers in the end. So this is the core of our solution. So then we met reality. Lost events. I already said it. We were aware that we might lose events, we might lose data, so we already provisioned something about it. And I think our solution prohibits this, and we have some robust solution found. Nevertheless, we checked this in reality also. Additionally, while implementing it, one of the big discussions was also about API changes or not. Let me go into details. Yeah, I said, okay, we try to prohibit the loss of events. I already elaborated on that. And then we also were faced with some inconsistencies in the API. For instance, my favorite example is the OpenStack flavor reference. If you provision a new virtual machine in Nova, you reference it by a flavor ID, but if you retrieve it, you don't get the flavor ID back, but you get the flavor data. And so it's, from my point as an API consumer, it's some inconsistent API. I would expect that the same data I put into a resource or into an API, I get also back from it. And yeah, this was a long time ago, and there are good reasons to do that this way, so I will not criticize it, but this is something we have to cope with during the implementation. And finally, maybe one of the challenges here is testing. So how do we do the testing? We cannot simply build up a cloud with hundreds or thousands of virtual machines, or not so easy. This is also very cost intensive. So we chose to build a mock service. So we have a mock service for the OpenStack API, which is not complete OpenStack. So it won't work with some OpenStack CLI client or so, but it's sufficient for our needs. It can work with the resources we currently work on, and it's a full REST service OpenStack API, but it's a mock, so it doesn't do anything real, which has the which is positive for us because we can use it in development. So we do not need to wait for some real resources to be provisioned. We can just put it in and it's immediately there. We immediately have a virtual machine or network or storage or whatever we need. It's immediately there. And we can test against it, and we can in particular do some load testing and exception testing. So we have not yet finished it, but one idea was to do some chaos engineering by dropping down packages or removing messages from the queue or doing something else to do exception testing on a technical level with the mock service, which is not so easy with a real infrastructure as well. So that's it from my side. I hope you got an idea how we implemented it and what we were faced. Thank you so far. Any questions? Yeah? Just start with one question and then we'll see.
Ah, ja.
Yep.
Danke.
It works.
In the start of when you start to build the stuff, then the solution would be to have your sync job or the shop job that syncs, checks everything is there, and that will put in everything.
Yes, exactly. This is one possible starting point. Usually we think that, okay, we start with the very first provisioning of the infrastructure, so we get the events immediately from the very beginning, but yeah, sometimes you need some bootstrap where you already have some infrastructure in place, and then you want to gather it via the sync endpoint or via the sync solution. Yes.
Then I make a statement instead of a question. I want this as the implementation of the SCS tender, because this is what we wanted to, or what I wanted to specify back then.
Okay.
What came out was something different.
Okay. Thank you. Any other questions? No, then I hope we are just in time. A little bit late. No, okay.
Thank you very much.